Hello everyone, my name is Ehsan Shopkusar. I'm a Senior Solutions Architect at AWS, specializing in media and entertainment content production. I'm going to give you an overview of our Ingest and Metadata demo. We're demonstrating unscripted production workflows on AWS. These types of shows tend to have many different types of recording devices, from action cameras to drones to phones, security cameras, and of course, professional cameras. The idea is to make sure you capture every moment from as many angles as possible and give the editors flexibility. But during ingest of all this media, there are two problems we need to address. First, all this media coming from different sources with different resolutions, frame rates, and color profiles need to be converted to a standard show format to make the editor's job easier and more efficient. Second, we need to create proxies that are small enough to distribute and are also playable without special software so that all stakeholders can review the footage. For this demo, we've created an automated and scalable workflow to handle both of these tasks. Let's first take a look at the generic version of the workflow before diving into some details. In order to process the footage in the cloud, we first need to choose a tool to upload our footage into an Amazon S3 bucket. Once the upload is complete, a message is placed in an Amazon SQS queue, signaling that there's footage available for processing. The next step is to analyze the footage and determine the source in order to be able to decide how to process the clip. Once the metadata is extracted, it's placed in another Amazon SQS queue, ready for further processing. The next process will convert the incoming footage to the standard show format and to proxies and place those results in an Amazon S3 bucket. The footage is now ready for the editor, but most editing software still requires file storage. So as the last step, we copy these clips onto a file server, which can then be mounted on a cloud workstation. Each of these steps in this process is a standalone, and there are many tools that can accomplish any of these tasks. So next, we're going to take a look at the specific tools that we chose for this demo. For the upload tool, we're using Pomfort Silverstack Lab. To extract the metadata, we're using Colorfront Transkoder, which has a probe functionality that reads the media directly from S3. We're also using Transkoder for the transcode process. We use a feature in Transkoder which allows us to upload proxies directly to Frame.io. Finally, for our cloud storage, we use Pixit Media's Pixstore along with Ingest, which allows us to expose the media on S3 as stubs only until a read request is made. Only at that time is the binary data pulled into Pixstore. Now let's take a look at this automation in action. In Silverstack Lab, I'm offloading a mix of MOV files from a DJI camera and some MXF files from a Sony camera. I'm going to name the library with a show code, today's date, and a number, and offload the clips. Once the clips have been offloaded, I can then upload them to S3. And as each file upload completes, a probe job shows up on Transkoder, which extracts the clip metadata. And once we have that, a render job shows up on Transkoder, which renders the final show format and proxies that we're after. If we look in our Frame.io account, we can also see the proxies showing up there automatically. And finally, the same files that are ending up on S3 are also being made available through Ingest to Pixstore for our editor to pull down and start working on.
Hi, I'm Alexei from AWS, and in this video I will focus on the metadata part of this demo. Here we are showcasing solutions from our partners Moments Lab and Strada, which help with automatic analysis and tagging of media content to help production staff build better stories in the short time available. Looking first at the Moments Lab, this solution uses AWS machine learning services such as Rekognition, as well as their own machine learning models for content analysis. If I pick a single file from this event, we can see a short summary of what was happening in this video. We can see who was appearing in this video, and also the breakdown into sequences and shots. If I open this media, I can look more precisely or more closely into which sequences the machine learning model from Moments Lab detected automatically and how these were broken down into shots. This particular sequence only has one shot. If I look at this one, there are multiple shots. And picking one specific shot inside a sequence or the whole sequence, you can see that the selection on the timeline is changing, and I can add this moment to cart if this is of particular interest to me. So for example, I want to include this in my final cut later. If I have enough content in my cart, I can choose to export all of them. I must give it a name, and I get to pick which format the file will be exported in. For example, let me pick MP4 for this demo. And after I requested this export, it will be progressing in my cart history. If I know that certain event happened in one of the videos, but don't remember which one, I can use the search. For example, I know for sure that in one episode, Chris de Bourg appeared in one of the sections. So I can search for Chris de Bourg, and looks like I found a couple moments where either they were mentioning him or when he appeared on screen. And again, I can move to these media pieces and add them to cart and then export. But what I can also do, if I'm preparing this for another person, like for an editor or for a director to pick and choose from, I can save this as a collection, give it a name, and save. And then it will appear on my collections page. Now let me highlight the other solution that we're showcasing here called Strada. Strada accesses the files and runs them through their analysis, including facial recognition, object recognition, transcription, translation, to name the most prominent, and makes the results of this analysis searchable across the whole library of content. Strada can access your cloud drives like S3, but it also has integration with popular tools like Frame.io. One feature of Strada that is particularly convenient is called stacking, which is what it sounds like. You can select several video files and create a stack by timecode where the videos will be automatically synced by the timecode. And this is an example of deliverable that is tedious and time-consuming to produce, and that would usually be created manually. So having stacking feature can make life easier for the production staff. Metadata that is generated is accessible through the Strada interface, so you can see where certain objects or people are appearing or where certain action is happening inside a video. But you can also export this metadata, so you can also have it available inside your NLE. So to summarize, in this demo, we're showing how cloud-based solutions from Moments Lab and Strada can be used to speed up production process for unscripted content like the LOL show, using machine learning for quick metadata generation and content tagging. Thank you for your time.